आज के क्लास में हम लोग सर्किट कंपोनेंट देखते हैं. Circuit component, that means we used the component in any circuit or electrical circuit. Circuit component. There are three circuit component we used in electrical circuit. Number one, resistor. Number two, inductor. And number third, capacitor. The property of resistor is known as resistance, and the property of inductor is known as same inductance, and the property of capacitor is same as capacitance. Now, first, resistor. Resistor, it opposes the flow of current. And the law of resistance is R. It's represented as R, and its electrical symbol is this, and its unit is in ohm. And the law of resistance says that R is directly proportional to L and R is inversely proportional to A. Combine the both term, we can write R is proportional to L upon A, where L equals to length and A is the cross-sectional area. So R is proportional to L upon A. We know that when proportional is removed, then R equals to rho L upon A, where rho is known as resistivity of material. Simple. Or we can say that rho is a constant depending upon the nature of conductor and is known as specific resistance. Say that specific resistance. Now, one new term is conductance. So the reciprocal of resistance is known as conductance. It's represented by G. So G equals to 1 upon R and R equals to 1 upon rho into L upon A. So we can write A upon rho into L, where one upon rho equals to kappa, and this kappa is known as conductivity of material. And rho R equals to rho L upon A, so rho equals to R into A upon L. The unit of R is ohm, area meter square, and length meter. This meter will be cancel out, so unit of rho is in ohm meter. So kappa equals to 1 upon rho, so the unit of kappa is per ohm meter, and per ohm we can write mho. So we can say that the unit of kappa is mho per meter. Now the next term, inductor. Inductor. The property of inductor is it opposes the change of current. The electrical symbol of inductor is like, and it's represented as L, and its unit is in Henry. H. When an alternating current is passes through an inductor, then inductor produces an mmf. So this mmf equals to N into I. And when the alternating current is passes through any coil, then coil produces the flux. So flux equals to mmf upon reluctance. This reluctance equals to R equals to L upon mu A, where L is length, A is the cross-sectional area, and mu is the permeability of the medium. And mu have two terms, that is mu equals to mu naught into mu r. This mu is the permeability of the medium with respect to air, and mu r is the relative permeability of the medium with respect to air, and relative permeability of the medium. Relative permeability of the medium. In case of air, the reluctance will be higher. In case of air, the R is higher, so flux will be lower. And in case of any iron, reluctance will be reluctance will be low, so flux will be increases. And we know that if my current is alternating, then my flux also alternating. So phi t equals to n I t upon r. And according Faraday's law, we know that Et equals to n d phi upon dt. So Et equals to n d n I t upon dt. So Et equals to we can write on next page. Et equals to n d phi t upon di into di upon dt. This n d phi upon di is known as self inductance. This L is known as self inductance. Now we know that L equals to n d phi upon di upon di. So L equals to n d n I upon r upon di. So L equals to n square upon r di upon di. So we can write L equals to n square upon r. Next, capacitor. The property of capacitor, it opposes the change of voltage. It opposes the change of voltage, and it's represented as and it's denoted by C, and the unit of capacitor is farad. Where C equals to epsilon naught A upon D. Here A is the cross-sectional area of plate, and distance between D is the distance between two plates, and epsilon naught is permittivity of the medium. Actually, we know that capacitor is a charge. Capacitor have a charge storage capability. So Q equals to Cv. If we differentiate it with respect t on both sides, then dq upon dt equals to C dv upon dt plus V dc upon dt. We know that the rate of charge is known as current, so I equals to C dV upon dt for dc upon dt equals to 0 because C is a constant. So we can write I equals to C dV upon dt.